Everybody, thank you for all the great questions during the Lunch and Learn, and we really appreciate that. So I've had the pleasure to be working in the FPGA industry for the last 25 years. And during this time, we've seen a lot of great innovations in FPGAs. It started with a very small number of gates, and now we have Ashlings devices have the highest speed fabric in the industry. In that, we have DSP blocks with variable precision floating point. We have AR tensor blocks. And we use these components to build up our RiscV based processor called Neos 5. And 24 years ago, we saw ARM processors introduced into Altera devices. So my team develops Quartus and Altera's RiscV based processor called Neos 5. And we partner with Ashling for the IDE to help you guys debug your applications efficiently in our devices. Oh, gotta get the clicker. Okay, so today I'm gonna discuss three main items: the challenges that you guys face and the significance of having really great debug tools. I'll give you a few methods on improving your productivity. And I'll give you a glimpse of how we're aligning with the industry in the future and give you guys a chance to influence it as well. So some of the challenges that you face when doing embedded design are typically that the device that you're targeting is resource constrained in terms of how efficiently the processor runs and how much memory you have. Systems have to be power efficient. In my past experience, we worked with a company that was building a collision avoidance system where the power budget was only 5 watts because it sat right behind your rearview mirror. So that was quite a constraint to deal with. You'll have real-time constraints like collision avoidance systems have to respond in a certain number of nanoseconds. Then you have heterogeneous systems. So in Ashlings 5, you'll see that it has Cortex A76 processors in it, as well as Cortex A55 cores. You have to integrate this with the FPGA fabric, and then you might have synchronization issues with the fabric. And you'll have limited visibility into your system in hardware. And finally, you have complex algorithms like a TinyML application that is running on the edge and will have certain latency and privacy constraints as well. So we would like to hear what are your challenges with heterogeneous debug. So if you don't mind, pick up your phone, take this poll, and we can see what kind of challenges you guys are having. Anything goes. Maybe we showed the results a bit too quick because I'm sure there's more than 0 responders out here. So, oh yeah, there you go. Compatibility with attach, multiprocessor, complexity, yep, time sync, yeah, okay, they keep coming. Okay, so let me try to touch on some of these items during the talk here. So I think the significance of having excellent debugging tools is key. Let's go to the next slide. Okay. So first line, it streamlines your development process. Having a single IDE to target multiple types of processors is really important, so you kind of stay in the flow. Finding issues early will help you in cost efficiency because finding issues later in the development cycle are very costly. Third, it helps you fix and debug the entire embedded system because if you can debug the processor interaction, as somebody pointed out here, it's really important to be able to do that in the tools. And finally, with FPGAs, you need to be able to future-proof your designs. So you need to be able to scale up to many more processors than you originally have. And that's one of the benefits of FPGAs, is it allows you to do this in your development cycle. So let's take a look at a couple multiprocessor use cases. The first one on your left, the ARM processor is running Linux, typically the higher level function like the user interface. And the soft cores that are in the fabric are doing real-time processing. So they'll set up, say, an image processing pipeline, and they'll monitor it during a runtime. The second use case on the right is a case where the HPS is running the entire application, and the soft cores that are in the fabric are monitoring the HPS, or the hardened processing subsystem, for correctness. So in safety-critical applications, you may see that. So now that we've looked at the challenges and the importance of having debug tools, let's look into our solution that we have to offer you. So as I said earlier, we've been partnering with Ashling for a number of years now to provide you risk-free. It has an integrated tool chain of compilers, debuggers, project management. It takes the export from Quartus and seamlessly brings it into this tool. That information is things like memory maps, system IDs, things like that. It supports NEOS 5, as well as NEOS 5 with custom instructions. That's the value add that FPGA brings to the table. And as well as the ARM processors in the hardened processing subsystem. It's RTOS aware. You can debug Linux kernel mode applications, device drivers, user space applications. It supports all devices that are supported by Quartus Pro. And there were some questions during the lunch and learn about the CIMIX simulator. It supports the CIMIX simulator, so you can simulate before you go to hardware. So the really important aspect is to also support multiprocessor. So up here on the top right, you'll see the light blue circle is the Cortex A53, for instance, in the system, and the dark blue is the NEOS 5M. So you can do both heterogeneous as well as homogeneous debug. You can have a combination of different OSs running as well as bare metal running. And it supports halting, resuming, and execution of individual cores independently. Okay, so now we can't forget about the FPGA fabric as well. So we have integration with SignalTap. So here's an example where you've put a breakpoint in your software code on the top left. And then you set up your trigger conditions in SignalTap for your logic that is in the FPGA fabric. Now, an important note is that both SignalTap and the Ashling tools share the same JTAG cable. Now, when you step over the breakpoint in your software, a trigger condition can happen in SignalTap. You'll capture your data. And then a very innovative feature that we have released in, I think, 24.1 is that we have the ability to take the data that is captured by SignalTap and bring that into an RTL simulator to give you full visibility of your design under test. So that lets you really explore and pinpoint the issue in your design. So you can see how the Ashling tools and the SignalTap tools can coexist and help you debug the entire application. Okay, so then let's take a closer look at a TinyML application. I think earlier in the day, Jim was up here and he talked about the development flow where you train the model. In this particular case, we are using the MINST data set to train an ELINet model. We go through the process of converting that TensorFlow Lite model into TensorFlow into a TensorFlow Lite model. We do the testing and performance accuracy on your development workstation, but it's nothing like seeing it actually work in hardware. So the bottom row there, it's the typical development process that you have in Quartus, where you use Platform Designer to build up your system. It could be a NEOS 5 that you're targeting, or an HPS. And in our example that we were showing in the booth, it's both HPS and a NEOS 5. Connect up your peripherals, set your memory map, add in your custom RTL, maybe your custom instructions, and you export the board support package to the Ashling tools. Now, in Ashling tools, it's really important to be able to do certain things to verify that your application is working and performing as expected. So you can simulate your system or emulate your system using CIMIX. You can do compatibility checks to make sure that all the TF Lite operations are compatible with the TF Lite micro interpreter that is running on the device. Now, one of the problems that we ran into is that we picked a model that was too big for the Neos 5, so we exceeded memory right away. So you can make sure that that's set. And then the next thing we ran into was our stack and heap was too small, so we updated the linker scripts for that. Now, when you're integrating this into an overall system, you may have sensors on your device. They may be pre-processing the data, so you make sure that the data is really formatted the way you expect it to before it gets into your model. And then you can do layer by layer verification. So in this case, we have the same model running in the HPS at a higher precision, and we have a kind of a tier down version of that model running in Neos 5. So we can do layer by layer verification between the HPS and Neos 5. And then lastly, you want to verify that you've met your performance requirements and your latency requirements, so you kind of look for blocking operations that are happening in the system. Okay, so let's move on to the third area, which is aligning to the industry standards. Now, I've already mentioned that we have Neos 5. Neos 5 is a RiscFree based processor, so we've already aligned with industry standards in that area. But I also want to talk about how we're aligning on the tools side of things. So our current RiscFree IDE is built upon Eclipse CDT. It's the same framework that is used for ARM DS5. But Eclipse Foundation announced back in 2017 that they're moving on to a next generation platform. This is called Thea. It's both cloud as well as desktop-based platform. Now, ARM has actually moved over Kiel MDK over to Thea. But Thea is all built upon Microsoft Visual Studio Code. So I have a very controversial question for you now. So which integrated development environment do you guys use? So I know this is a hot topic, so if you could just take this poll and let's see what everybody uses these days. Yeah. Ah. Cursor. I'll take VA code as VS code. Okay. I'll wait for a little bit more. You want it? Okay, good. No. Okay, let's, okay, good. This aligns with what we were thinking. So let's move on to the next slide. Okay, so back in 2024, there's a Stack Overflow survey that was done with 44,000 professional developers. And as you can see the results here, 74% of them were using Visual Studio Code, and another third was using Visual Studio. You can see that Vim is sitting there in 5th place, and Eclipse is way down there in 12th place with 9.2%. So that shows you where the industry is kind of heading. At this point, let me introduce Rajesh. He is the VP of Engineering at Ashling, and we've been partnering them for many, many years now, and he'll give you a glimpse of the future of heterogeneous debug.
And thanks, Nabeel, for the intro. And yeah, very excited to see the Paul also here because I'm going to talk about the VS Code. Yeah, just before I get started, I'm Rajesh, VP of Engineering at Ashling. And we have been working together. We and Altera have been working together for, as Nabeel mentioned, some time now. And essentially what we do is we provide debug tools for the Altera FPGAs. And when I say Altera FPGAs, yeah, it means both the ARM HPS and the Neos 5 softcore. And Nabeel have been talking, of the nice features of the Eclipse-based RiscFree IDE. And what I'm going to do is I'll take a glimpse, take you through what we are right now working on, and what you could expect pretty soon from us. So what you see in the screen right now is actually the VS Code-based solution, the VS Code extension for Altera FPGAs. And with that image, what you see is actually the simultaneous multi-core heterogeneous debugging using the VS Code. So that itself gives an idea where we're heading, where we're already there. And if you take a close look, actually, you can see both the Neos 5 call stack and the ARM HPS call stack in one instance of the VS Code IDE here, which shows like how easily we can debug both using the VS Code extension. So talking about this extension again, yeah, while it has all the features being supported by the RiscFree Eclipse-based IDE, there are a few things we were focusing on. So one of them is that actually whoever has used VS Code today, which I know almost 75% of people and almost 90% of people sitting here, like whenever we want to debug a system, debug a target, we actually have to go in and edit a JSON file, a launch.json file as it is called, and we have to put in all the information into that particular file, like what is debugger we are using, what is application I'm going to debug, and all the environment settings, my compiler toolchain, everything. So what we have done is that we have brought in a graphical user interface, a GUI interface, pretty much as what we have today for an Eclipse-based solutions, what we call the debug launch configurations. So what it actually makes life easy in the sense like we don't have to go and edit the JSON files. Actually, I don't have the screenshot for that here, but we have a live demo running there. So once you visit there, you can actually see this exact same sequence, the heterogeneous multi-core debugging running there, and you can see this graphical user interface configurations as well. And we also have this auto-detect feature, what we call. So what that means is that we don't have to have any knowledge of the underlying system in the Altera FPGAs. Just in a single click of a button, it will actually list down all the devices in the FPGA, and just from the drop down, choose the device, whether being an ARM HPS or a Neos 5 softcore, just choose the device and start debugging. So that way there is no need to be preparing a file again, kind of an OpenOCD configuration file with the scan chain details. That is not required either. And this, again, how this is going to work is that all of us have the VS Code IDE in our system, and just install this extension, what we call the VS Code extension for Altera FPGAs. And once we install the extension, this extension will take care of installing all the other software requirements, like the cross-compiler toolchain, maybe for Neos 5, all the debuggers, all those things will be installed, and our environment will be set up all seamlessly, and we can start building and debugging and the application straight away. So it's kind of a single-shot installer. It's as easy as installing the extension and getting started. And this is going to be part of Cortex tools from Q1 25. And we also have an early access program, which again, Nabeel will be covering soon. And now, just add to on top of that, it is not just that we are working on the extension, we are also adding support for code spaces. So what that means is that, again, in our laptop or desktop, whatever we have, we don't have to have any setup done there. All we need is a browser. So get your browser, and all this Altera reference code, the FPGA reference code will be in GitHub. Go to GitHub, press a button for code spaces. So if you know the concept how the code spaces works, it just creates a virtual environment, a virtual machine for us to start working. So go to GitHub, Altera GitHub, press this button, get a code space environment, and there you install this Ashlings VS Code extension for Altera FPGAs, and that will ensure the complete environment setup is done within the code space, and there you can actually start, again, the same thing, build your application, whether being for Neos 5 or ARM HPS, start debugging the application. So we can do it actually on a remote FPGA board as well. So all you need is a secure VPN connection. So get the VPN connected ready, and then using our browser, we're actually downloading and debugging the application running on the FPGA board, which might be set up in a board farm. So that's the other thing we are now focusing on. So we have the VS Code extension, and then we have the code space support as well. So what I have in this slide is I'm about to give a glimpse of the real demo setup, what Nabeel have been talking about, simultaneous solution. So before I play this video, what we have seen here, just explain my demo setup here. It's actually a TinyML application. So the ARM HPS, we have the Sapphire application, Sapphire RTOS-based TinyML application, and for Neos 5, we have a bare metal TinyML application running. So what we see here is actually the debug configuration, the launch configuration from RiscFree Eclipse IDE. And this is what I was talking about. In the VS Code extension also, we'll have the same interface. So the transition will always be seamless. If you're using an Eclipse-based IDE today, to move it from Eclipse-based to VS Code will be very seamless. And here, if you take a close look, actually, you can see both the ARM configurations. So you can see the cores being selected, Cortex A55 and then the Neos 5. So both the cores being selected in a single launch. And when I press debug over here, the actual debugging will start. And what you see on the left is the different UARTs. What you see on the bottom is the UART for the ARM HPS, and what you see on the top is the JUART terminal for the Neos 5. So here, I'm just playing the video. I'll just try to work with that. You can see the different configurations being done for the Neos 5 and ARM HPS. And once we press the debug button, you can see the connections being made. So the Neos 5 connection is being made, the ARM connection is being made, and then we'll have the program download. So ARM first stage bootloader or second stage bootloader is being downloaded. You can see the download application download going on there. And then we'll have the TinyML Neos 5 application being downloaded to the target. And then once all the connections are made, you'll see all the call stacks, everything are getting updated. And then we'll be in a situation to debug both the Neos 5 and ARM. So you can see now both the Neos 5 and ARM cores are listed there. It's all happening in an Agilex file system. And just free on the target, you can see both of them running in parallel. So this is what we have for the demo setup there. And again, what is interesting is that we actually have the VS Code demo running over in the booth. So the same thing, you have seen here how things are working using the RiscFree Eclipse IDE, but on the booth you can see how things are working with the VS Code extension. So with that, I'll again go back to Nabeel, and he'll talk to you more about the early access program and all. Thank you.
So it really was seamless for Rajesh to move that application over to VS Code, because we asked him to do it last Thursday, I think, and a couple days later he's got it going. So just to recap, I discussed some of the challenges of heterogeneous debug. Talked a little bit about some tools and some ways to improve your productivity. We showed what was coming soon. And we'd like to give you an opportunity to sign up and shape the future of our debug tools. So if you scan that QR code, we're going to accept the first 25 early access customers. And this is, again, your opportunity to influence the tools. So I hope you can come by and see us at our booth. We'll be showing this TinyML application there. And again, thank you for your time.
Altera, accelerating innovators.